Let's start with two of the simple versions of using the law of cosine. For these problems, you have the option to use law of cosine multiple times, which in my opinion is the best way to do it. Because even if you only use the law of cosine once, you can always use the law of sine. It still works. But law of sine, as you'll remember, often has some issues, especially when the angles were obtuse. They could have multiple different solutions appear. And so the law of cosine will be the superior one for all of our homework problems tonight and for the rest of this week. I strongly recommend doing it every chance you can. Sometimes it'll involve being creative. That's the third problem we're going to look at as an example. The first two are the most simple kind. When I'm given three pieces of information I'm asked to solve, and the three pieces of information happen to be good pieces. Here's the first example. Find all the missing side and angles based upon what is given to us. We have the following three pieces. We got 30 degrees for alpha. We got B is 12. We got C is 24. That means we are given three pieces. We got to find the other three. Now, as a reminder, we'll be rounding everything to one decimal place for this section, and everything will be done in degrees. So my recommendation, as is common with these kinds of problems, do with the law of sine, draw the picture first. It does not have to be an accurate picture. It needs to be a precise picture. A needs to be opposite alpha, B needs to be opposite beta, C needs to be opposite gamma. As long as that is the case, your picture is not as important as most of you think it is. Let's draw this thing. Here's my beautiful, beautiful picture. Yay. I put my alpha in one corner. In this case, my alpha is 30. And A is going to be across from alpha. A was not given, so I put it as an A. My beta is going to be another corner. Which corner? A corner. Okay, and then across from that is going to go B, 12. And then my gamma is going to go in the third corner, and across from that is going to go my C, 24. As long as that information is accurate, the rest of the problem does not matter as much as you think. But A needs to be opposite of alpha, B needs to be opposite of beta, C needs to be opposite of gamma. So let's talk law of cosine. The law of cosine requires three pieces and has two different versions of the formula depending on what you're looking for. If you are looking for a side to start with, the first one is the best version. If you're looking for an angle to start with, the second one is the best version. Now that being said, there are three pieces of information given. One of them is best to start with because of what is given to us. In this case, what you want to look for are three pieces in the same vicinity. In this case, these three. The 12, the 30, and the 24 are all in roughly the same proximity on the triangle. That is an indication that you'd be looking for the side C. And it's a good, or in this case, alpha, I should say, A. If you have those three next to each other, that's the best place to start. It's the easiest one to work with. And if you don't have those ones next to each other, you can still work with other ones, but we'll often force our third example where it gets a little more complicated. You have to use some other techniques to get the solution. So when possible, you want to look for a situation where you have three pieces of information given to set this thing up. Now, in your textbook on page 777, there are 6 different versions of the formulas. 3 for the first formula, showcasing what happens if you solve for A, what happens if you solve for B, what happens if you solve for C. There are also 3 different versions if you solve for alpha, beta, and gamma. In general, though, all these versions are very, very similar. And in fact, for this first problem, the exact version that's written on the board is the one we're going to use. A squared is equal to B squared plus C squared minus 2BC cosine of alpha. So we're going to plug everything into that formula. And my goal is going to be to get one of the pieces isolated by itself. So that's what I'm going to do. I'm going to take those pieces and plug them in. Now you'll note that neither one of these formulas are fully simplified. I don't have just A by itself already. So when I get finished, I'm going to have to take one additional step to solve for the missing piece. So for this first one, at the end, I want to take a square root to get A by itself. For the second one, I want to use an inverse to get the angle by itself. Let's set it up. My formula is A squared is equal to B squared plus C squared minus 2BC cosine of alpha. I'm going to take the information that was given in this problem, I'm going to plug it into this formula and start trying to simplify. Once you've got all the information plugged in, you can go ahead and just grab a calculator and start plugging and chugging. That is totally reasonable in these kinds of problems. However, if you do not have a calculator with you, you can do a lot of it by hand and get pretty far down before you actually need one most of the time. So here we go. I'm going to ask, let's see, Joel, you have a calculator in front of you? Can I ask you to take the right-hand side, once I've got everything written down, can you plug it all in and give me one solution for me? Well, I kind of work through a couple steps on my own up here, and we make sure you get the same solution. So up here, we have A squared is unknown, so A squared is still A squared. My B is 12, so I do 12 squared. My C is 24, so I do 24 squared minus 2 times my b value, which is 12, times my c value, which is 24, times cosine of my alpha value, which is 30 degrees. Make sure your calculator is in degrees. Most common mistakes in these ones is plugging in the formula wrong or having it in radians. Most common mistakes. Okay, so most of this can be done by hand, but not all of it. Example, if I do the 12 squared, I can do that by hand. It may take a little bit of time. 24 squared, 2 times 12 times 24 can be done. We're lucky on this one. Cosine of 30 is on the unit circle. Some of them you will be able to use the unit circle for, some you won't. Calculator is your friend. So, let's see. If you put all that into the calculator, you should get the following solution as a squared is equal to, let's see if I remember, it is 720 minus 288 square root of 3. All right, I'll do it by hand. 12 squared is 144. 24 squared is 596. Minus 2 times 12 times 24. 2 times 12 is 24 times 24 would be 596. Cosine of 30 is square root 3 over 2. Okay. Like I said, trying to do it all by hand is kind of fun. You can do as much as you can by hand if you want to. Calculator is fine. Don't feel pressured to do it all by hand. Calculator is just fine. I just don't have anything else to do right now. So a squared equals 576. Not 596. 576. Thank you. That was going to mess some stuff up later. Okay. Thank you. Good. Much better. Okay, so now I'm going to simplify the rest. 144 plus 576. I add the 4, that becomes 580. Add the 40, that becomes 620 at 720.
If it was plus 576 and minus 576, why we cancel those?
Because this is times square root of 3 over 2. I have to do multiplication before I can add and subtract, whatever it is. 576, I can do the over 2. If I divide that by 2, I get 288 square root of 3. And that is what I get by hand if I do it. Was that what you guys got? The calculator?
No. I got 221.
Oh, good. You got the decimal. Fine. Perfect. You got the decimal. Now to get A, I have to do one more step because I don't want A squared. I want A, so I have to square root both sides. Last step. Square root both sides, whatever that happens to be. So go ahead and take that square root and tell me what you guys get.
14.9.
That's what I got this morning. So I hope that's right. 14.9?
Yeah.
Beautiful. Okay. Remember to round it to one decimal place for all problems. Beautiful. We found the missing side. Okay. The problem said to find all missing sides and angles. There was one missing side. We found it. There are 2 missing angles. Now, at this point, I'm going to add this information we just found back in the triangle above. And when I do so, I have the option to use the law of cosine again, which is what I will do. I could also do the law of sine, but as we saw in the previous problem, because you're given different pieces, the law of sine can have multiple solutions. And so it is possible that by doing it by the law of sine, I end up having to do more work. The law of cosine is a more strict formula. It has a lot of pieces to it, but it works every time, no exceptions. And so when possible, I will tell you, use the law of cosine. The law of sine is the weaker of the two in terms of the usefulness because it gives you multiple solutions. Whereas law of cosine is just one. Okay, so let's take that 14.9, let's put it in. Because now that we have that piece, we can actually do a lot more. Thank you. All right. A is 14.9. I can use the law of cosine again to find one of the angles, but it will mean switching formulas. I'll have to use the second formula instead because the second formula has it for the angle instead. Now, the thing is that I could solve for either beta or gamma, and I could in fact solve for both using the law of cosine once each time. The law of cosine is nice, but still the law of cosine takes some time to do. I will use the law of cosine to find one of the missing angles, and then I'll use the triangle angle sum theorem to find the other. Okay, here we go. Now, die. All right, come over here. All that work is great. Beautiful. It found the missing side. I'm now going to find beta. I could find gamma. It's not going to matter. It depends on which one is it. You could find beta, you could find gamma, and just find one of them. And so I'm going to find beta and use triangle angle sum theorem. So to do so, you notice this version is the alpha version. In your text on page 777, there are all three versions. One solved for alpha, one solved for beta, one solved for gamma. What I would encourage you to do is look at these formulas and note they are all very similar, and it's all about their position in the triangle. Here's the cosine and beta formula. Let's explain what it looks like. Cosine and beta formula is equal to, it is going to be a squared. This is why I don't like having my door open. A squared plus c squared minus b squared all over 2ac. You notice this is different from the alpha formula, but what I want to point out here is if you look at the generic alpha, beta, gamma triangle, the formulas all reference things that are either adjacent to it or opposite to it. So if you look at this picture, the two sides being added, A and C, are the two that are adjacent to beta. The one that's being subtracted is the one that is opposite of beta. And if I remember that fact, it's always true for every version of these formulas. The ones being added are the ones adjacent to the angle I care about. The ones that are subtracted are the ones being opposite to the angle I care about. So knowing that information, I can rewrite this for beta. I can also rewrite it for gamma. If you don't want to learn how to rewrite them that way, you can also just write all three versions of them on your cheat sheet and have them available to you. Remember, they're on page 777. It's in all of our textbooks. It's there available to us. Okay. There's our formula. I'm now take the information in my triangle, which I now have. I have B right here. This is my B value. I have C right here. I have A right there. I'm going to plug all that into my problem and get cosine by itself. I will then, once I have cosine by itself, want to get beta by itself. So I'll use an inverse to finish the problem. Here we go. I plug them in. I plug in A squared, so cosine of beta is equal to A squared, so that'd be 14.9 squared, plus C squared. C squared is 24 squared, minus B squared, that's 12 squared, all over 2 times 14.9 times 24. Plugging into my formula. At this point, like even me who loves doing math and enjoys plugging in numbers for fun and doing answers and stuff, I'm grabbing a calculator. There's no way I'm doing that in my head. No way I'm even going to try. Don't care enough. Calculator time. I'm going to take 14.9 and square it. I'm going to take 24 and square it. I'm going to subtract 12 square it. I'm going to divide it by that big number, 2 times 14.9 times 24. And I will get some kind of decimal. Once I have done that, I then get beta by itself using the inverse. Let's go ahead and take that first step. Simplifying the right-hand side. Cosine of beta is equal to. What'd you get?
0.9.
Give me a couple decimal places.
914.
One more.
4.
Beautiful. Okay. So on the right-hand side, we get that decimal. Beautiful decimal. Very nice. We're now going to use an inverse to get the answer. So my last step to finding beta, I do cosine inverse of both sides. Beta is going to be equal to cosine inverse of this number, 0.9144. I know the problem says around a 1 decimal place. When you're doing the actual physical math, it's better to keep a couple extra decimal places to get you a more accurate answer, especially if you're going to use the inverse. The inverse is very finicky. If you're off by even a single decimal place, it will give a very different answer. So, like it says round, but only round at the end. So let's go ahead and plug it in the inverse, and we get the following number for our angle beta. Round it to 1 decimal place this time. Cosine inverse of 0.9144. And I get the angle is 23.9 degrees. Okay. Going back to my picture, I have all three sides. I have 2 of the angles. I got to find the last angle. I can either do the law of cosine a third time. Don't do that.
Can you do the triangle?
Yes, do the triangle angle sum theorem instead. Make sure that all the angles should add to 180. So to find gamma, I'm going to go back and use the triangle angle sum theorem. I do 180 is equal to alpha, which we said was 30, plus beta, which is 23.9 degrees, plus gamma, the unknown. I then get gamma by itself. Gamma ends up being 100 and 26.1.
Yeah.
And here's the thing. We could have used the law of sine to find gamma. Once we found A, we could have used the law of sine to find gamma. But we actually would get the other one. The option B, the second answer, is actually the one that gives us gamma. Remember how I said it gives you two triangles? Well, in this case, the second one was the right one. And you won't know that without doing more work. So the law of cosine eliminates the possibility of that second angle. We also found cosine and beta directly using the law of cosine. If we had done cosine and gamma, we would have gotten 126.1 or very close to it. Remember, rounding errors can throw things a little off, but not much. So again, the law of cosine is the superior one when you can use it. So if possible, use the law of cosine. There'll be some problems on our tests, on our final, where it'll say, use the law of sine to solve this problem. And there'll be other problems that say, use the law of cosine. And there'll be one problem that says, just solve. You can use either technique that you want. Whichever one you think will work best, use it and see if you get the answer. Okay? This is example number 1. We found all three pieces of missing information. We use the law of cosine twice. One for the first one, one for the second one, and use the triangle angle sum for the third one. Let's look at the second type of problems we have tonight. Also pretty similar. This time, instead of being given one of the angles, we're actually given none of the angles. It's kind of cool. I like it. So let's look at our second example. Alright. Example number 2. Find all missing pieces of information. So in this case, find all missing angles. In your homework, the long problems are the ones that say find all of them. There are other problems in your homework that are nice and say only find this one. Find only beta. Find only alpha. Find only gamma. Or A, B, or C, whatever they label them as. Make sure you read your directions. Don't assume you have to find all of them. Okay, read your directions. This problem says we have 3 pieces of information given. A is 5, B is 7, C is 10. So let's go ahead and start by drawing our triangle. When I'm giving all 3 sides, it's easier to make it accurate, but remember, it doesn't matter. What matters is A needs to be opposite alpha. B needs to be opposite beta. Let's set it up. Triangle. Yay. Here's my alpha. There's my beta. There's my gamma. Alright, A is opposite of alpha. B is opposite of beta. C is opposite of gamma. There's my triangle. Yay. So exciting. On a problem like this, it is impossible to do the law of sine. Because if you look at it, the opposite ones, there's no angles. So I can't set up an equation with one variable. It is impossible. So in this case, this is one where the law of cosine is the only one that works. Now, I'm going to solve this problem by solving gamma first. Could I solve it for alpha first? Yeah. Doesn't matter. Could I solve it for beta first? Yep. Good. I'm choosing to solve for gamma because I want to get some practice rewriting this formula. Remember, there's 3 different versions of this formula. I want to make sure you get some practice using it. So let's solve for gamma. To solve for gamma, my recommendation is to remember how these pieces all fit together. So in this case, the 2 numbers being added are the 2 that are adjacent to gamma, that are make gamma form. The one that is being subtracted is the one that is opposite of gamma. So in this case, in my picture, gamma is right here. So the 2 that are going to be added are the 7 squared and the 5 squared. The one being subtracted is the 10 squared. On bottom, we have 2 times, and again, the 2 that were next to it are the ones that end up on the bottom, so 7 and 5. Sure. It's just a modified version of this formula, so can I call it 2b, or is that too Shakespearean? Sorry. Cosine of beta would be a squared plus c squared minus b squared all over 2ac. Cosine of gamma would be a squared plus b squared minus c squared all over 2ab. And again, these are on page 777 in your text, or if you don't have a textbook, at the beginning of section 10.2. I believe it's like the first page on section 10.2. Well, I've done is plug into that formula. Okay? From here, I start simplifying, and once I've simplified down as far as I can, I then use an inverse to get gamma by itself. Let's do it. Cosine of gamma is equal to, if you got a calculator, go ahead and type all that in for me, and I'll make sure mine matches yours. 7 squared is 49. 5 squared is 25. 10 squared is 100. 2 times 7 is 14 times 5. 14 times 5 would be 70. Okay. Please, somebody check my calculator. Cosine of gamma is equal to 49 plus 25 is 74. Minus 100 would be negative 26 over 70. I'm not going to bother simplifying any farther because I'm going to immediately grab an inverse. I invert both sides to get gamma by itself. Gamma is equal to cosine inverse of this fraction, negative 26 over 70, which gives me the following solution. I do cosine inverse of negative 26 over 70. And get 111.8 as my angle theta. Using inverse. That's really nice. So I use cosine of gamma's equation to find gamma. Sorry, I'll slow down so you can see. So I just simplified a bunch. This can be done with the calculator. And then I do an inverse. Needs a calculator to be done on this last step. You can't avoid a calculator. Unless you have like a fancy table that happens to have some of these nice numbers in it. Even then, it's still a pain. Calculator is kind of required once you get to this step. And then we just plug it all in and give our solution 111.8 degrees. That was one missing angle. If the problem only required me to find gamma, I am finished. If the problem says find all of them, I got to keep going until I have them all. So let's go ahead and take the next step. I'm going to find either alpha or beta. Whichever one I don't find, I can find using the triangle angle sum theorem at the end. The people who are good with the formulas can work these problems real fast. The people who are good with calculator can work through them even faster. It's nice. I love this section if you're a calculator person. If you're not, I'm sorry. We're ending the year this way. Could go back to graphing if you want. All right, here we go. I'm going to find cosine of beta this time. So I take my picture. I'm going to scroll over here. I'm going to find beta this time. So to find beta, I use my formula. Cosine of beta, in this case that is version number 2 up there. Cosine of beta is equal to a squared plus c squared minus b squared all over 2ac. And plug everything in. All my pieces. Cosine of beta is equal to a squared, so that would be 5 squared, plus c squared is 10 squared, minus b squared is 7 squared, over 2 times 5 times 10. All right, this time I'm going to skip. I'm not going to do that by hand. Calculator's my friend. Let's use it. 5 squared plus 10 squared minus 7 squared, all divided by 2 times 5 times 10. 0.76. So I get cosine of beta is equal to 0.76. Now to get the beta by itself, I use an inverse. So I will do beta is equal to cosine inverse of that decimal, 0.76. And I will get my solution, which is cosine inverse, 0.76. 40.5 degrees. So we found gamma using the law of cosine, 111.8. We find beta using 40.5. Using the law of cosine again. I could do the law of cosine a third time if I really wanted to, if I'm just crazy that day. But I'm going to use a triangle angle sum theorem because I'm lazy that day. So let's find the last angle. We do 180 equals my alpha, which is unknown, plus my beta, which is 40.5, plus my gamma, which is 111.8. All right, and then I get alpha by itself. 27.7. Yay.
I think that's right.
Alpha, 27.7 degrees.
Because I found that one first, so.
Yeah, nice. So thank you. She went and found alpha first because if you have the alpha formula on the board, it's probably a little easier to do it that way than do it the way I did. And she still got the same solution. That's what should stick out. She got 27.7 without needing to do the other two steps first because she knew the law of cosine. Law of cosine is designed to work this way. And again, it might be off by a single decimal place, maybe a couple decimal places if it's a bad problem. But in general, the law of cosine is very nice because we avoid the law of sine problem having possibly duplicate answers appearing. And so, very nice. We have one last example. In this example is the ones that will be the most trouble in the homework. Most of the ones we see in the homework are like these ones, more than half. The other type is what happens if it doesn't have a nice setup. We try to use the law of cosine and it doesn't quite match what we need. I'm going to actually do a homework problem that is based on this. This is actually one of your homework problems. This is number... Nope, not that one. Not that one. Not that one. That one. Yes, this is number 11. Okay, we're going to do number 11 together. So this is what happens if you happen to try the problem, and when you plug it into the formula, it ends up not being nice. Here's the trick. You'll notice when we do at the end, it's kind of nice. Number 11. Number 11 has the same instructions as the previous ones. Find all the missing piece of information. The pieces they have given me on number 11 are gamma is 113 degrees. B is 10. C is 32. If I go to put this into the triangle and then plug in the formula, there becomes a problem. Here we go. I make my triangle. Okay, my gamma is 113. And across from gamma goes C, there's 32. Across from beta is going to go 10. Alpha is not known. A is not known. There is my triangle. Is it drawn to scale? Nope. All the pieces are there. That's what matters. All right. Here's the issue. If I go to use my formula up here, even if I adjust it to get the 113 to be the number that I plug in, what I get out of it is not nice. Here we go. I'm going to focus the problem around the 113 and use the first formula. Try again. Around the 113 and use the first formula. When I do, the formula is not as nice as the previous two examples. Something weird happens. And when that happens, I can tell you exactly what you're going to do every single time. And it might be the reason why there's a formula on the board. Might be a good reason.
Are you looking for all the missing sides and angles?
Yep. So we're looking for all the missing sides and angles. Let's do it. I'm going to plug in the formula. Now in this case, I'm using gamma. So my setup is going to be as follows. C squared, which is my gamma, so that would be 32 squared. Maybe I'll put the formula. C squared is equal to A squared plus B squared minus 2AB cosine of gamma. This is an alternative version of the first formula. I'm now going to plug the information in. I could work with the second formula and try to find one of the angles. I promise it's harder. If you have one of these that's like this, try to find the missing side first. It will be easier because you can use this shortcut. But I'm given gamma.
That determines what formula.
That determines the formula we're going to use. Okay? The angle we are given determines the formula we should use. So I'll show why in a second. Here we go. I plug it in. C squared, so that'd be 32 squared, equals A squared, which is unknown, so A squared. B squared, which is 10 squared, minus 2 times A, which is unknown, times B, which is 10, times cosine of 113. So there is my crazy cool formula. Now, I may not look at it right now, but once you simplify, this becomes a quadratic. Like once you go to calculator and plug all this information in, it becomes a quadratic very nicely. Now, as I do this step, do note the quadratic equation has a requirement for you to use it. It must be equal to 0. That will come up here in a moment. Here we go. My left-hand side, 32 squared is 1,024. Hopefully. Yay, thanks. A squared is A squared. 10 squared is 100. 2 times A times 10. 2 times A is 2A. 2 times 10 is 20, so negative 20A times cosine of 113. Cosine of 113 is not on my unit circle, so if I have a calculator out, and type in cosine of 113. This gives me the following answer. I get for cosine of 113 negative 0.3907. Notice I'm getting a couple extra. That way I have a good, accurate, reliable answer. I don't want to round until the end.
Did you multiply the 2 and 10?
Yes, that's why I got 25. And I'll simplify one more time. I get 1024 is equal to a squared plus 100. And then, okay, 20 times that number. So negative times a negative would make that positive. And then 20 times that decimal, 20 times 0.3907 is 7.814a. This is a quadratic. I want to make that very clear. If you do this correctly on some problems, specifically 7 through 15, your first couple, which I think was rude. Your first ones are your hardest ones. A little rude. But on number 11 and ones like it, you'll end up with a quadratic. And guess how you solve it? Quadratic equation. Now, the cool thing is the quadratic equation gives two answers. If you have the calculator, Daisy, you know how to use the function keys to find the solution of the quadratic equations? So we can speed up a little bit.
Oh, but you have to subtract the 1024 from the 100, right?
Yes. Before I can do anything else, in order to plug in that formula, I need to get this equal to 0. That is the last step before I grab a calculator. So I will subtract over this 1024. Because remember, I cannot do the quadratic equation unless it equals 0. So I get 0 equals a squared. I'm going to put it in the correct order. Plus 7.814a minus 1024 taken away from 100 would be negative 976.
924.
What? I made the same mistake last walk. That makes me sad. I didn't learn from my mistakes. So now at this point, once you've got it down to a quadratic written in this form of equal to 0, go to the quadratic equation. Plug it in. You got the calculator that does it for you. Do it for you. The quadratic equation will give you two answers. One of them should be positive, and one of them will be negative. It's important to remember, you're drawing the side of a triangle. The negative answer is wrong. On my calculator, it should be mode 5 and then number 3. So press the mode button, press 5,
Oh, hold up.
and press 3. You can then type in the numbers, the coefficients of each piece, and it will tell you the solution.
Oh, okay.
I know. Mode 5, 3. It's great.
Just fill in A, B, and C.
Yep. So in this case, plug in for me, Giselle. Plug in 1, plug in 7.814, and then plug in negative 924. And it should give two solutions. The one that's positive is correct, the one that's negative is not. What do you get? You plug in 1 for A.
1 for A.
Hit enter. Plug in 7.814 equals 7.814 equals. And then use the negative symbol, not the minus symbol, the negative symbol. 924. So everybody else, she's plugging in the coefficients of these three values and finding our two solutions, one of which is wrong and is obvious to the thing. Yep. What'd you get as your two answers?
26.74.
26.74?
And negative 34.59.
Cool. Quadratic equation gave us those two. Guess what? That was wrong. Last week. This is the side of a triangle. It cannot possibly be negative. You can have negative angles, but not in a triangle. You can have negative numbers, but not on sides.
So A equals 26.74.
That's right. And to find the rest, you can use the law of cosines more times. You only have to do the quadratic equation once ever if you do it right. So make sure to do it right. We'll practice some of those tomorrow, and then talk about Huron's formula.
How do you go back?
It's quit. Should be one of the keys. I'll come over there.